Hopefully you guys can see my screen now. 4.4. Yeah, right on. And is the streaming software working? Let's check the YouTube. Stream set up. Looks like it's good. Yeah. All right. So, good morning to everyone that's here today. Let's see who we got on the call. Destin, Julia, Matthew, me, Sam. We got a few people in class. Lucky them. We're just finishing our breakfast because we had, of course, I bought breakfast for everyone at Broadway's today. Hey! All right. And don't be shy, the kids at home. If you need to contribute or ask questions, you're free to do so. Anyone have any special plans this weekend? I'm talking to the kids at home now because the kids that are here, we've already had our discussion and I'm tired of talking to them.
Yes.
Okay, is it a mystery or are you going to tell us about it?
I might see some family and we might see some family friends too.
Okay, good stuff. Anybody else at home doing anything special? All right, well, I think today is Jahim's birthday. So maybe what we'll do is we'll sing him happy birthday and then it'll be in the video and then we're going to wait and see on Tuesday if he says anything. And then we'll know whether he watched the video. Are you guys ready? People at home ready? All right, here we go. 3, 2, 1. Happy birthday to you. Happy birthday to you. Happy birthday, dear Jahim Java Fruit. Happy birthday to you. Nice. Yeah. Woo. That hurt my ears, but that's okay. It's the thought that counts. I was just listening to myself. So let's do a little 4.4age here. And did y'all have any questions about 4.1, 2, or 3? I know that one of them was not actually a lesson. I think it was 4.2. Did you guys have any questions about exponents? I know Mr. Smith did a little work with y'all when I was at badminton the other day. Everybody good? No homework questions? Come on, Destin, you don't have anything for me? Or Julia, you guys are usually good for a couple questions.
Actually, I have one question.
I knew it. What's your question?
Wait a second.
DK, Donkey Kong. Anybody see the new video, the new movie? The Nintendo or Mario Brothers movie? It's out. My daughter went to see it yesterday. Yeah. Oh, that's what I forgot to do. She brought me back popcorn and I forgot to eat it last night. Oh, I'm so mad. I forgot. Well, because she came home at dinner time, I had to go to pick her up at the train station in the middle of dinner, and then I had to eat my dinner. Otherwise, I wasn't allowed to eat popcorn. And then, of course, I was too full to eat the popcorn, and then I forgot to eat the popcorn. But in fairness, she didn't get real butter on it, so she kind of ruined it because she put the golden topping. Not the same. Okay, DK, what's your question?
It's 229, and it's the 7th question.
229, 7th question. Good morning, James. How are you? Good. You want to play some badminton? Pure 2. Don't invite anybody. Just because you're not getting good practice with those guys. They're no good. If your brother's here, then you can play your brother. Yeah. But yeah, I'll be happy to. Pure 2, okay? All right, Dustin, you said, just to repeat, page 239?
Yes.
All right. Let me go to our workspace.
29.
229. Okay. So let's go to page 229. I'm pretty sure I have it open already somewhere, but it might not be the right one. Oh, come on. Yes.
Oh wait, why don't you just eat the popcorn today?
I probably will if there's any left. That's the issue.
Okay.
You know what I'm saying? I'm going to show up, my bag of popcorn is going to be empty. So then I'll be eating air. I'll be eating popcorn flavored air. And it's not the same on the second day. Even a couple hours later, like, I eat my popcorn so fast because I'm afraid it's going to taste stale if I don't. I remember when they used to give you free refills too on the popcorn. Not good. Not anymore. I don't know. Yeah, pre-COVID they stopped doing it. At Landmark? Oh, you need a special card? Okay, 229. Anyway, maybe I'll go to Landmark so then I can have 17 different flavors of Coke. Yeah. Okay, 229. What question was it, Destin?
7.
Okay. Oh, unfortunately, I don't know how to do it, so let's move on. Yeah, I'm kidding. Which one?
I was going to ask, how can we do these questions without using a calculator?
Oh, excellent question. So, which one do you want to do?
MC.
All right, let's do C. Let's do this. I'll take a picture. Screen capture. That's what I want. Back to the book. Whoop. Back to my screen capture tool. Whoop. Oh, they don't ask you to do it without a calculator. They say predict the order of these 6 expressions. So they just want to know what's the biggest number, what's the smallest number, and when they ask you to express it to 3 decimal places, you're supposed to use the calculator for that. So question number 6, you're not supposed to use a calculator. But 7 you are.
Okay.
Okay?
Can we solve the 12th question then? F12F.
We can. Yeah. So that one you're probably going to use a calculator for it, but I'm not 100% sure. But give me a second. Let me do this again. Hey, I'm trying to take a picture. All right. So if we look at 12F, if you're trying to do it without a calculator, then you're trying to be slick about it and replace things that are confusing with things that are less confusing. So for example, the first thing that stands out to me is the exponent 1.6. So 1.6 is what fraction? So that would be 16 over 10. And then if I reduce that fraction, I can divide those by 2, 8 over 5. And that means I have negative 7.776 to the power 8 over 5. Do you agree with that, Destin?
Mm-hmm.
All right. Now, which part of the exponent is the root? Is it the 8 or is it the 5? Destin?
Are you asking me?
Yes. What are you eating?
I'm eating breakfast.
I understand that this is the appropriate time to eat breakfast. I'm asking you for a more specific answer. What are you eating?
Starbucks, what do you call it?
Starbucks?
Starbucks hot breakfast.
Starbucks what?
Not like the sausage hot breakfast, the egg wrap.
Well, if you went to Starbucks, why didn't you come to school?
I didn't want. I ordered.
Okay, fine. Oh, you did Uber Eats?
Yeah.
Oh my god.
I didn't know there will be a lesson.
You guys. No, that's okay. I'm not mad about that. Okay, so does anybody know which of the part of the exponent is my root? Tells me which root we're dealing with.
Isn't it the 5?
It is the 5. Now, what I suggest to you guys is to break them up into two parts. So I suggest rewriting it as negative 7, 7, 7, 6, with the root and then the power on the outside. Now, you said it's the 5th root, correct? So I have to write it like that, and then it's the 8th power. Does everyone understand how we're able to break it up into two operations like this? And I'm looking at the 14 people in class this morning as well. So the people that are at home, it's okay. You're just going to miss the math party. So could you all evaluate this in some way? Well, ask yourself, is negative 7, 7, 7, 6, is the 5th root of that possible? It is? I thought we couldn't take roots of negative numbers. What? Well, it depends. Depends on which root. It's an odd numbered root. There we go. The smart kids are in the class and the other kids are at home. So because it's an odd root, not odd as in strange, but that's an odd number, then you can, so you know your answer's possible, and it's going to be a negative answer. Is 7776 a 5th power of a number? I'm going to guess either 6 or, what is it? Is it the 5th power of 6? So Destin, did you know that, is that what you're saying? Are you sure, or you're going to make me look bad in this video, right? Oh, it's on the board. There we go. Who asked? Was Destin not here? You asked? Oh, okay, cool. Thanks for telling me 15 minutes later. What?
Shouldn't the 8 be in the radiant, like in the roots?
No, it doesn't matter. You can do, if you have 8 to the power 4 over 3, that can be written as 8 to the power 4, and then, 8 to the power 4 to the power 1/3, or it can be 8 to the power 1/3 to the power 4. Do you agree that they mean the same thing? Because with the exponent rules, you can convert them, either of those, to this here. So it's your choice which operation you do first. I will usually suggest doing it this way because it takes a big number and makes it smaller by taking a certain root. And then after that, you can find the power that's specified. So now we can evaluate negative 6 to the power 8. And if I do that quick calculation in my brain, I get, oh, it's a different question. Anyway, I get to the power 8, well, I have 36 times whatever that number is. So what's the number? What do y'all think?
I think it's going to be an error.
Well, it shouldn't be an error. I put my bracket in the wrong place here. Because that negative, unless it's inside brackets, that negative is outside here as well. So if I look at the question, did it have brackets? Oh, it did have brackets. Okay. But it still doesn't matter. So, yes, we're still going to get the same answer. It's going to be negative. Actually, it won't be negative anymore because it's to the power 8. Anybody know what it is? What's 6 to the power 8?
Like a really big number.
Well, why don't you spell it out for me?
Oh yeah, sure. 1679616.
I've seen bigger numbers than that before. It's not that big. So that is 1,679,616. And that's the answer. Does that make sense, Destin?
Yes, it does.
And the nice thing is, it was only this last step that required a calculator. And when you tried to punch it in, you got an error. When you tried to evaluate the original.
Yeah,
But
Yeah,
it's not an error,
because-
and you understand why, right?
yeah. Because it's now the root is an odd number, so it doesn't matter whether it is negative or positive.
Correct. So who's the best?
You are.
Oh, that's so nice of you to say. All right. Are we good with questions? Are we done? Oh, somebody put their hand up. I'm excited. Let's go and look at the chat and see who asked the question. I hope the video is working. Something's going on here. Oh, it's working. You guys worry too much. Google Meet. Who put their hand up? Matthew?
It was me.
Go ahead.
I have a question about the knot space that we did
Yes.
yesterday.
What's your
The day before.
question?
It was on question 7. I just wondered why it's like -3 is to the power of -10 to the power of 2.
Wow, that seems like an impossible question. Okay, what question was it? Number 7?
Yeah, number 7.
Is that what it looks like right there?
Yeah, that's it. I
Okay,
just didn't know which one it would be.
so you just want me to give you the answer.
No, I didn't do it.
What a cheater. Okay, let's figure this out. Look at that, I took a picture of it again. Skills to pay the bills. Okay. I don't know what I just did there, but oh, that's what I did. Okay. So you've got -4 to the power -8. And because this is an even power, you know you can disregard the negative. You could also combine the powers because you have a power of a power, so you could rewrite it as -4 to the power -16. Are you good so far?
Yeah.
Okay, now we know that, like, you might think, oh, there it is, it's right there. But it's not, it's actually this one here. Because the reason that it would be this one is because this answer here is negative, and this answer here, yeah. You see what I did there? You guys see it? This is a happy face, smiley face. It could be a frog. It looks like a frog. So the first answer is negative. This answer here is positive. Well, your answer should be positive because you've got an even power. You understand what I'm saying? And what I was saying about brackets is if it doesn't have brackets around it, well then that negative is outside, and this should be a negative value, but your answer should be positive. Is that good?
So if the power is like an odd number, it would be like negative?
Correct.
The answer would be negative?
Correct.
Okay. Yeah, that makes sense.
Right on. All right, well, let's move on unless there are any other questions. Okay, so let's do the lesson. Today's lesson is brought to you by 4.4. Expressions involving exponents and solving exponential questions. So look at all these words. Expressions involving exponents and solving exponential equations. So we're going to use the exponent rules that we reviewed the other day because we already knew them, but we just had to review them. Did you guys like the worksheets that Mr. Smith gave you?
Yeah, I enjoyed them.
Excellent. I'll pass the compliments on, and I'm sure he'll be pleased. So let's look at some examples of equations that have that necessitate using the exponent rules. So look at this here. They're giving you a ratio of surface area to volume, and this is important in science. It's one of those relationships that limits how big cells can get. You guys ever seen big cells? There's this giant cell that looks like this. It looks like a tree, but it's this thing called acetabularia. And then there are different versions of it. This one here would be crenulata. Look it up on the Google if you like. It's a green algae, and this is a single cell. And many cells have these things called, I tried to change colors, but it didn't. Does anybody recognize that part of the cell right there that I just drew in green? Great. It's the nucleus, yeah. Way to answer after I said it. Anyway, it's the nucleus. But all of that to say that cells are limited to how big they are because cells get their food primarily through diffusion. So diffusion means things just move across the barrier. Could be osmosis if we're talking about water. But if the cell gets too big, like this, let's say that's the big cell, well, in order for food to get to the middle, that the diffusion has to travel too long a distance from the outside of the cell. So surface area to volume is an important ratio. You guys probably don't care about that, and it's kind of we're out on a tangent. So let's get back to our question. So surface area to volume ratio is something that you might encounter, and they're asking you to simplify this expression. Well, there's nothing to simplify here, but if I replace SA at R and V at R with what they are, R, I sound like a pirate, R. Well, then I would replace SA at R with 4 pi R squared, and then I would replace V at R with 4/3 pi R cubed. And so you might think about using your exponent rules, and more specifically, we're dividing an R by another R. So what can we do? Keep the base. We're going to keep the base. And what are we going to do with the exponents if we're dividing? We're going to subtract, right? So my exponent on R would be -1. Y'all down? Okay, now what about pi and pi? They're just numbers, right? Can I cancel them out?
Yes.
Okay, I can cancel them out. And the reason I can cancel them out is because they are, say it, Starts with C and rhymes with almond factors. That's exactly right. Good job. Because they are common factors. How do I know they are common factors? What's not there between things on top and things on bottom? Correct. You're not adding or subtracting. They're factors. These are multiplications. 4 times pi times r times r. 4/3 times pi times r times r times r. Those are factored versions of the equation. What's left are the 4 and the 4/3. Now it's 4 divided by 4/3. What does that make you guys think of? Dividing by a? Yeah! Makes you think of flipping things. I think what you're trying to say, DK, is changing a division to a multiplication. And you can't just arbitrarily do that. If you're going to change a division to a multiplication, you must reciprocate the second term. Is that what you're trying to say?
Yes.
Boom. See what I'm saying? And if you would like to express it using only a positive exponent, you would have 3 over r. Nailed down? Excellent. Shall we try a second example? Fantastic. Let's connect the exponent rules to the simplification of this algebraic. Well, if you're asking yourself, can you cancel stuff? Well, hopefully we can, but what are we going to do here? Is this in factored form? Yes. Is this in factored form? You're right, it is in factored form. Can I do the following? Okay, you're right, I can't do that because what I just canceled are not because of this. Okay, so can I do this? Everyone in class says no. People on the line, you're saying no? Good, I'm glad, because this is not correct. This, you have to expand by Oh, well, thanks. A little late to the dance there, but nah, better late than never. So that's what we would be looking at. And that's going to end up being something messy, like you're going to have x cubes, x squares, x, and numbers. So you're going to have a 4-term polynomial. Sure. So we know we're not going to do those things. What can I do something to simplify the numerator and the denominator in this expression? The answer is yes. I'll do the hard part. 2 cubed. Does somebody want to do the next part? Okay, so Emma said x to the negative 9, and that would be correct. And what do you say there, ice cream? Correct. Now, I'm curious. Why am I allowed to do that here, but I said I'm not allowed to do that here? Yes, because there's an addition here. That prevents you from cubing each of these individually, and you have to expand and simplify it. You have no additions here, so you are able to do that. All right, Stella, do the denominator for us. Negative 8? Yeah? Good. And that can further be simplified. Somebody at home want to give it a try? You guys still there?
Yeah.
All right, nobody wants to do it. No problem. Go ahead there, ice cream. I'll do the hard part. 8. Okay, do the easy part. Do you understand the hint I'm giving you? You have x to the power negative 9 divided by x to the power 6. So you're going to keep the base and do what with the exponents? It's a division. If I had...
subtract them.
You're right. If I have 2 to the power 3 and I'm trying to divide it by 2 to the power 1, that would be the same as 2 to the power 3 minus 1. Cool? Okay, so you've got x to the power negative 9 divided by x to the power 6. That'll be x to the power what? Excellent. And then the same person that was at home there, why don't you tell us what this one works out to?
Alright, so it would be 6 plus 8, so it would be 14. Why 14?
I heard you typing in your calculator that calculation.
No.
I heard it. I heard it, guy. My goodness. Yeah, let's do a little more mental math, okay? Come on, Steak. All right.
I don't have a calculator on me.
Yeah, I wish we could believe you. Where's your phone?
Oh, yeah.
Exposed. The phone. Everybody knows the phone has the calculator. All right, it doesn't matter, okay? You'll get there eventually. So we simplified it. That's fantastic. Good job. Oh, somebody else joining? Oh, look at this one. Here, this is your first fail of the day, guys. Nobody can do this. You guys have no clue what's going on now. I just got to figure out what happened there. Someone wants to join. Will Harms. Come on, Will. Think I'm going to allow you entry? Chump. All right. So, let's go. Who wants to do this one? What are you doing? All right, go ahead. What are we doing with the exponents? We're going to add them. So we're going to go 2n plus 1 plus, notice I put some brackets around there. They're not essential in this case just because I happen to be adding them, but they might be useful at some point. Oh, sorry, are you going to do it all in one shot or can we do it in two? Okay. And here's something that you guys might miss. How do I know? Because I marked your tab. Still people getting peed up because they're not putting equal signs on their solutions. So make sure you've got an equal sign per line, please. Okay, so then we're supposed to add all these things. And what does that simplify to? Just 5n, okay. And then it's still divided by x to the 2n minus 5. Now what? I'm going to go up here because I'm running out of space. So I'm not getting peed up. And then what? Minus. And notice I bracket up again. And this time it would make a difference because if I hadn't bracketed up, I would probably make a mistake. The answer is going to be 3n plus 5. Because this negative changes the sign of everything in the brackets here. 3n plus 5. And they actually ask us to evaluate the expression. Evaluate means your final answer should just be a number, essentially. So we can replace x with negative 3. We can replace the letter n with 2. So that would be the same as having negative 3. Look at me bracket up like that. As soon as I replace a variable with something, it's a good idea to bracket up, because then we know that negative belongs to the 3. And then I have 3 bracket 2 plus 5. And this right here ends up being 13. So we have negative 3 in brackets to the power 13. And if I, sorry, what? 6 plus 5, yeah, exactly, 11. Who said 13?
Sir, maybe you should use a calculator.
Oh, yeah, okay, well, you're our expert on calculators, you use them for everything, so why don't you tell us what the answer is? What did the calculator make you for breakfast? Nah,
X.
I'm so funny. All right, so what's the answer? Goodness. More for us. So nobody's doing this. What's wrong? Sam, come on. Whatever. Have a good weekend. What's hello?
81. But it's not minus, it's plus.
It's not mine. It is negative.
No, but there's 4.
There's 11.
Oh, I thought it was 4, sorry.
This is what 4 would look like. Man, I'm getting criticized by everybody today. You guys are so mean to me. When I'm gone, you're going to miss me when I'm gone. You're going to miss me when I'm... You know the song. And the Kendricks, I think. It's not a good song.
I found the answer on the calculator. Would it be like negative 177,147?
That's correct. I just didn't want to steal the thunder from you guys. I did it in my head. You better be right, Julia. All right. So I think we're good. This last question here, I'll show you how to be slick with it.
From Area 2, grade 7 classes will go to Ms. Stack's room 131 and Madam Lethal room 134. And grade 8 will go to the Sunday Gym. Thank you.
Okay, you guys are going to go to room 131 because I want to go to Starbucks. So go to Miss Stack's class. Goodbye. Yeah. Okay, I'm just kidding. Stay there. So you see here you've got A, B, A, B. That's cool. I would, when I see a number like this, I think of replacing it with something. Can anybody guess what I would replace it with? What? No. Did you say, 3 power 3? Yes. I would replace it with 3 to the power 3. And then this 16, I would replace with 4 power 2. Or, yeah, I'd probably go 2 to the 4. I like to do that. And the reason that's useful is because when you go to take the half power or the third power, oh look, divisible by 3, boom. Look, divisible by 2. So those become 3 to the 1, nice. And that becomes 2 to the 2, nice, which is 4. There's nothing wrong with making it 4. Okay, that's just a little tip. And, oh, look at this example. Oh, mess you up. Why don't you guys try to rewrite that in a way that would be useful, that'll allow you to simplify it. I'll give you 30 seconds. All right. Any ideas? Spaghetti? Ice cream? Did you pick a food? What's it going to be? Egg roll? Have you had an egg roll yet? Okay, next week. Next week, when I get Lucky Star, I'm going to order you an egg roll. It'll blow your mind. Okay, so nobody here has any idea. They're clueless. What about at home? Okay, you two stop fighting over who gets the mic. Oh, forget it. Somebody here has an idea. Silence at home. Yes. Sorry, a little louder because I can't hear you. Yeah. I'm not sure if this is what you're saying to me here. X to the power 8 over 5 over x to the power 3 over 2. Is that what you're saying? To the power 3? So here's what you should be thinking. You should be thinking that this is the same as that. Okay, that's the numerator, and this is the denominator. Excuse me. People at home understand that?
Not really.
I don't know what to say now. Now I'm mad. No, I'm not mad. So whatever you've got under a radical sign can be replaced with the exponent with the index in the denominator. So if I have 9, if I have the square root of 9, that's like having 9 to the power 1/2. But 9 is also 3 to the power 2. And it also is not no in German. That's funny. Do you see how this simplifies? What does it become? You got a power of a power. It becomes 3 to the power 1. You all understand that? Okay, excellent. So what did I do? I took my root, which happened to be a second root or a square root, but it doesn't matter if it's the second root. It could be the 7th root. If it's the 7th root, I just change the denominator in my exponent to 7. You guys get that? So if I scroll back up to the original question, I had x to the power 8, no problem. And then the 5th root of that. Well, that's the same thing as x to the power 8 to the power 1 over 5. You all agree? Great. So now, if we look at the denominator in the orig, what can I replace that with? I replaced it with x to the power 3. Well, it was already x to the power 3. Okay. And then to the power 1/2. Why? Because it's the second root. They're equivalent. Now are you down? Right on. And don't forget the old cubic out there. Now we're going to use our exponent rules. And how about Matthew? Just deal with this right here. What's the exponent rule that we use here? Power of a power. I got the power. What are we doing? Yeah, so what's 8 times 1/5? It is 8 over 5. That doesn't look like a very good 8. 8 over 5. Nice. Steak, talk to me.
What's going on?
I just circled it. Tell me, what's up?
It would be x to the power 3 over 2.
Nice. I don't know why I have this here, that extra line. Let's get rid of that. Back to our pencil. Blue. X to the 3 halves. And don't forget the old cube. Nah, the old cube. I don't know why it came up as a 1, but alright. Extend page. Julia, what are you thinking next?
I think I want to subtract 3 over 2 from 8 over 5.
I think that's an excellent idea. X to the power 8 over 5 minus 3 over 2, which would be, oh, we can't do that straight up, can we? What do we need? Oh, you're close. Yeah, we need a common denominator, not a common factor. So how do we find our common denominators? We multiply creatively by 1. What's our common denominator? 10. So what are we going to multiply the first exponent by? No. 1. Try again.
2 over 2.
That's better. 16 over 10. And DK? What about the second exponent? What are we multiplying it by?
5 over 5.
Ah, good job. Now, what did you guys forget? I told you twice not to forget. Yeah, don't forget the big old cube out there. Those big old clouds, like Bob Ross would say. And we're going to paint some big old clouds here. You guys know who Bob Ross is?
Yeah.
Good. So that's 1 to the 10. Whoa. What happened there? 1 to the 10. To the power 1 over 10. Big old cubes. 3 to the 10. How slick is that? Did we forget anything? Look at how that looks awesome. All right, I'm getting out of here before somebody asks a question. No, too late.
Well,
Whose hands up? Matthew, are you back?
Oh, yeah, it's back.
What's this? Oh, you're waving. Is that what that means?
Oh, yeah, wait, get back.
Okay, right on. So who had a question?
hi. So, what is preferred, to leave it as a radical or as a with the exponent power?
Sorry, what? No, I heard your question. Either is fine. So this would be okay. Or you can write it as x cubed to the power 10. Sorry, not to the power 10. The root 10 of x cubed. So that's an option. Let's just go back to the orig. Involving a single power. So they just wanted a single power, so you would leave it like this. Single power. Cool. Cool? Rock and roll. All right, so there's a little bit about, oh, this was the other stuff. I think there's a little bit about logarithms. Here it is, the logarithms. Let's talk about this. I'm sure you guys are dying to find out. Does anybody know what logarithms are? Well, let me tell you, you guys are going to be stoked about being able to use this on the weekend. So, when you have something like this, 2 to the power x, and you're trying to solve for x, it can sometimes be challenge. Let me give you an example. Could you ever solve for x?
Yeah.
Okay, tough guy, what would it be?
2.
What?
2.
2 to the power 2 is 41? Come on.
41. No.
Come on, man. Seriously? Okay, no, you're right. You're right. Look, this was what I had written down. And you would be correct. X would be equal to 2. But what if I changed it? And that's what I did. I went and changed it because I wanted to mess with you. Well, now what? Now you're trying to figure out what it is, right? And wouldn't you love to be able to BS this question?
Yes.
And that's what logarithms do. They allow you to BS a question where the unknown is in the exponent position. So let's take something that's it's going to be a little bit more interesting. Let's call it 135. Okay, so we want to know what power of 2 is equal to 135. Now, if I had left it at 132, oh, that would still work. But anyway, so what we're going to do is we're going to use logarithms to solve. And when you get to this stage where you have just one term on one side and the exponent is unknown, this is where you drop the logs. You just take the logarithm of both sides. I know you have no idea what logarithm means, but that's okay. So I'm going to show you how you use this tool. Once you do this, here's the magic that logarithms unlock. If you have the logarithm of something with an exponent, that exponent can be moved to the coefficient position. So then you have x log of 2 log of 135. Now, I want you to use your calculators, finally, and I want you to calculate log of 2. So how you do that is you find on your calculator a button that looks like this. And you press that button, you press 2, and then you press equals. What do you get? Wow. You guys not understand what I'm saying? Is it because I didn't close my rectangle here, you didn't understand that this is a key? You don't have your calculator?
I got 0.3010 bunch of numbers.
0.301. What? Okay, that's good. Four decimal places is good. Okay, so I'm just going to make sure that's the right number. Not that I don't trust you, but I don't trust you. And log. Wow, this calculator doesn't have a log. Oh, it does have a log, but log 2. 2 log. Some people you'll have to press the 2 first and then hit the log button. What's up? Oh, this
Julian,
calculator's messed up.
I need to tell you that your Wi-Fi is not working.
Unacceptable.
I told her that.
Okay, well, repeat it. And keep texting her until you get an answer from her.
Okay.
Yeah, that's fine. Okay, so the answer that you gave, was it Matthew or was it Steak?
There's nothing.
Who's the intruder?
Yeah.
Is that,
We don't know.
I'm guessing it's, what's his name? Carbonara. Sounds like Carbonara. Is it?
Yep, you are right.
Unbelievable. And you probably think I'm cheating, but the kids in class here know that I did not change the screen. I did not go and look at who's at the Google Meet.
Yeah, it's carbonara. Yeah, it's carbonara.
Oh, you liars. Who is it? Let's go find out. Oh, who are the others? Who's in the call? Oh, Zakuti. That was my next guess. Oh, Zakuti. Nice. Okay, well, good job, Zakuti. I'm so glad you're here. Finally, somebody smart on the call. Yeah. So, if I wrote 2x equals, what would you guys do next if we're talking about BS? 2x equals. What's the BS step? And you guys shouldn't say that BS, okay? That's just between you guys and me. On the test, when you write that, I laugh at you because you get no marks. You got to use big person talk. Otherwise, I'll draw a sippy cup on your tests. Come on, you guys know this. What's the BS step? 2x? I want to know what x is. Isaac?
I divide both sides by 2.
Thanks for answering after Isaac had already said that.
Oh, sorry, Isaac.
No, don't be sorry. Anyway, yes, you're right. Everybody's right. You all get participation ribbons. Divide by 2. So, we would divide both sides by 2. Everybody understand that? But why are we talking about dividing by 2? What should we be talking about dividing by?
0.3010.
Finally, you got an answer right. Good job. Yes, you're going to divide by this number right here, right? Because that's the coefficient of x. The other way you can look at it is just go back one step. What can we divide by? Go up one step. Divide both sides by?
Log 2.
Exactly. So that's what we would typically do. I'm going to erase all this. And now I'm going to divide both sides by log of 2. And it doesn't matter what you do first. Okay, so you'd have log of 135 divided by log of 2. And look at that, we just solved for x. So go ahead and use your calculator. Calculate log of 135. Divide that by log of 2. And it's going to give you an answer.
Yeah, 7.0768.
Zakuti, I'm so glad you're on the call. Man, finally, somebody legit. So what that means is that 2 to the power 7.08 approximately is going to be 135. And if you want to check it, just ask yourself, well, what's 2 to the power 7? 2 to the power 7 is
128.
okay, so we're just a little higher than 128, and that's correct, 135. So we just solved for an unknown exponent using logarithms. Slick? Now there's another button that you could also use on your calculator. It says ln, which means ln, or natural logarithm. And I'm going to save the explanation of the logarithms till next week when we're in class, if that's okay with you guys, because this class is almost over and I grow tired of talking to you guys. All right, so children at home, y'all have any questions? Are you guys stoked? Stoked about using logarithms this weekend?
Yeah, I love that.
I bet Mr. Brash's class didn't talk about logarithms. Did they?
Yeah, they did last month.
Last month. Well, it's
Maybe we
not.
could ask Will Harlem so you could let him in.
Oh, is that that an actual person?
He's a brass student, yeah.
Oh, I thought it was made up, as in like.
He's trying to learn the better.
Oh. Had I known, I would have invited him. Tell him next time we'll put him on the VIP list so he can get in. Will Harm. Yeah, no, I thought it was somebody trying to hack in our call. Keep the security tight here. So there are no questions? Right on.
I have a question.
Go ahead.
When's the math space due? Like, you have to do it by a certain date.
What do I do to be so awesome? That's a good question. Well, I wake up in the morning and I put my pants on like everybody else, one sleeve at a time, one pant sleeve at a time. Oh, sorry. When's the math space due? How about Tuesday?
Okay.
I don't know what I put on the math space. Does it not have an expiry date? Yeah, I think it's Tuesday anyway, so I actually was right again. Okay, I hope you guys have a nice Easter weekend and take care. And if your other teachers don't do Google Meets, just go on our math space and I'll put the YouTube video and you guys can watch it over and over again. Okay. Take care. Don't forget to hit the like button and subscribe, and leave your comments below so I can not read them. Take care, guys. Later.
Thank you.
Hey, hold on, Isaac.